In August 2024, the Lucara Diamond Corporation announced that they'd found a 2,492-carat diamond deep in the Karowe mine in Botswana. It's the size of an orange and the second largest diamond ever discovered. And while that might sound impressive to us, it's business as usual for the country it came from. This diamond is just one of many gigantic diamonds that have been unearthed in Botswana in recent years. Of the 10 largest natural diamonds ever found, 7 have come from Botswana. The country has some of the richest diamond mines on Earth. Only Russia produces more in number, but those stones tend to not be as big. So there's a lot we could go into here. How diamonds came to define Botswana after they were discovered in the 1960s, the unusual partnership between the De Beers Company and the country's government, and even the question of whether Botswana has really escaped the so-called resource curse, the notion that many countries with great natural resources often end up with worse outcomes. But underpinning all of these discussions is a single question: why here? How did this relatively small country come to win the diamond lottery so hard? As it turns out, it's a story that took billions of years to tell, and it involved some of the largest tectonic events in Earth's history. Today we're going to explore how Botswana just happens to sit in the perfect place to make it the world's best diamond factory. The first piece of the Botswana diamond puzzle requires us to go deep, really deep, deeper than the deepest mines. We need to go where humans have never been, the Earth's mantle, the hot inner layer of rock between the Earth's crust and core. See, some gemstones, like rubies and emeralds, form naturally in the Earth's crust, but diamonds don't. They only form in the mantle, and almost always in a particular region about 150 to 250 kilometers beneath the surface. It's here that you get the right mix of heat and intense pressure for carbon atoms to arrange themselves into that diamond structure. Now, being underneath the Earth's crust, the mantle is literally beneath everyone's feet everywhere on Earth, so you might assume diamonds are also ubiquitous, spread out around the globe more or less evenly. But that's not really the case. Diamonds are surprisingly finicky. If the temperature gets too hot, the carbon will actually start to melt into a liquid. Meanwhile, if there's too little pressure, you'll end up with cheap graphite, which we can turn into tiny little golf pencils. And here is the first clue as to why Botswana got so lucky with diamonds. The crust that makes up much of the country sits on what's known as a craton. Cratons are pieces of what geologists call the lithosphere, since they technically include both the crust and the upper layer of the mantle right below it. Cratons are especially thick, stable, and very, very old. For example, the Kapval Craton under Botswana has rocks that are 3.5 billion years old. So you can think of cratons as kind of like the nuclei or cores of the continents. And their upper mantle undersides, which lie about 150 to 250 kilometers beneath the surface, are the perfect places for diamonds to form. The extra weight of the craton pushes down on that underbelly, keeping the pressure high. And since the craton's rock is so stable, its little bit of mantle doesn't interact too much with the immense heat-transporting currents of turning rock in the rest of the mantle around it, meaning it stays relatively cool. I mean, it's still far warmer than anything a human could stand, something northwards of 900 degrees Celsius, but that's what counts as cool deep within the Earth. It's also the temperature that diamonds favor. Now, this pressure and temperature combo may explain why you're more likely to find diamonds in Botswana than, say, Florida or just out on the ocean floor, because those areas don't sit on cratons. And it explains why other places with cratons, like Canada, Siberia, and Brazil, do tend to be diamond hotspots. But the Kapval Craton under Botswana is a bit special. It's been subjected to a lot more dogpiling by continental collisions over and over again throughout Earth's history. Not only have those collisions made the craton thicker and stronger, they've also delivered more of the raw ingredients you need to make diamonds. See, the mantle does have some carbon in it, but when scientists look at chemical signatures in the diamonds themselves, including the little imperfections that got included as the diamond was forming, it looks like some of the carbon is coming not from the interior of the Earth, but something a lot closer to us. Seafloor subduction. That's when an oceanic tectonic plate gets pushed underneath a continental one, like what's currently happening to oceanic crust along the west coast of North and South America. This subduction drags the rocks of the oceanic plate down into the mantle, and also anything embedded in those rocks, such as carbon-based compounds. Meanwhile, it also brings down a fair amount of water, which can help with the chemical reaction that actually creates those carbony diamonds, which seems to need both hydrogen and oxygen. Eventually, Eventually, the subduction and melting triggers a kind of big geologic mix-up, and that chemical reaction on a gigantic scale. Geologists call the result a diamond-creating event. In other words, you get diamonds in big batches. Now, these diamond-creating events definitely happen in other places, but as far as anyone can tell, this has happened a whopping 7 different times underneath Botswana. At least. That's the most of any place we know, and it's all thanks to those frequent collisions this particular part of the world has experienced over billions of years.
Thanks to Cometeer for supporting this SciShow video. Cometeer is a new way of making coffee with no machine and no mess. They grind up the coffee for you, brew it, and immediately flash freeze it to lock in the freshness and flavor. Then you can make your own hot or iced coffee at home without having to do any of that work first thing in the morning. If you're the type to wake up early, you can switch to Cometeer and never worry about waking anyone else up with a loud grinder or using your not quite awake yet brain to finagle a giant robot that takes up half your kitchen. Just leave a frozen capsule in the fridge the night before you want to use it. It'll defrost overnight so you can wake up, fill your favorite glass with about 7 ounces of water and ice, pour the coffee right in from the capsule, and mix it up. With their variety of roasts from light to dark and even decaf, Cometeer has a coffee for everyone. To get 15 free cups in your first subscription, you can visit cometeer.com/scishow15 or use the link in our description box below.
So to sum it up so far, diamonds tend to form underneath very thick, stable pieces of the Earth's lithosphere called cratons, because that's where we find the immense pressures and relatively cool temperatures they need to form. Botswana sits on one of these cratons, but also some especially frequent tectonic collisions have delivered an abundance of raw ingredients and triggered more diamond-creating events than anywhere else we know about. But there's another piece to the puzzle, because all of that stuff might explain why there are a bunch of diamonds beneath Botswana, but that's still hundreds of kilometers beneath the surface. So how do they get up here? It has to do with the type of rock they're usually found in. If you're hunting for raw diamonds, you want to look for a kind of dark, heavy rock that's fragmented and filled with embedded crystals and greenish chunks. It's called kimberlite, and it's usually found in carrot-shaped cones that extend deep within the earth. As an igneous rock, kimberlite is cooled magma, but it's usually found far away from your typical volcano. Instead, kimberlite eruptions seem to happen right in the middle of cratons, just kind of bursting up out of nowhere in small but sudden and incredibly violent events. And we'd love to show you footage of one, but most of them happened tens of millions of years ago, if not even longer. The most recent kimberlite eruption happened around 10 or 11,000 years ago. As far as why kimberlites pop up, scientists haven't been able to come to a definite conclusion. But in 2023, a paper in Nature suggested that kimberlite eruptions may be due to vortices in the mantle that are created as a supercontinent breaks apart. A team of geologists was looking at the timeline of known kimberlite eruptions across the last 500 million years of Earth's history. And kimberlite eruptions don't seem to happen evenly across time. Instead, they seem to abruptly bloom, then die down again and again. Previous research had suggested this was related to plate tectonics in some way, so this team looked at what else was happening around those points in history, then ran some stats. They found that there wasn't anything taking place at roughly the same time as the eruptions that could explain them, but they did note an odd coincidence. If you rewound the timeline a little bit, you could see that kimberlite eruptions always seem to peak around 30 million years after a supercontinent broke up. Thanks to some computer simulations, the team revealed that as the continent wrenches itself apart, hot material from deep below the Earth can take advantage of this weak point and rise up in massive convection currents. This, in turn, creates a kind of vortex deep within the Earth at the border between the upper lithosphere mantle and the lower, hotter mantle beneath. Now, if this was water, such a vortex might quickly peter out. But in the mantle, they can churn for tens of millions of years, and as they do, they can travel, rolling along for hundreds or thousands of kilometers and working their way along the diamond-rich underside, melting and destabilizing it. The displaced rock plummets down, while an upwelling of hotter material from deeper within the Earth rises to replace it, like bubbles in a lava lamp. And remember that ocean floor subduction I mentioned a while back that brings water down into the underside of the continents? That water and other compounds also get heated up in the deeper mantle and begin to decompress and turn into tiny bubbles of hot, volatile, highly pressurized gas. So the end result of this vortex is a small amount of fresh, hot, diamond-carrying magma that can punch straight up through the craton above, carrying one or even multiple generations of diamonds along with it. And as it punches upward, it can encounter groundwater, vaporizing it and causing an even more violent explosion at the surface. As the ripple spreads outwards, this process repeats itself, creating a chain of hotspots that travels along with the vortex. This mechanism might explain how kimberlites around the world work, but again, Botswana might have massively benefited from this. Southern Africa has seen a lot of rifting in its time, like when Pangaea broke apart, followed by South America, India, and Antarctica all leaving Southern Africa. All of these may have been followed by kimberlite eruptions. So why is Botswana home to a massive supply of diamonds? It's because it sits on top of not just a geologic diamond factory deep within the earth, but on top of a craton that survived not just one, but multiple continent-spanning tectonic events that triggered a way for the earth to deliver those diamonds to the surface, including that nearly 2,500 carat monster from Karowe, and probably a few that are even bigger.